Welcome back to Keeping Current, the podcast for ERS and HVM designed to plug you into the world of electrical power systems. I'm your host, Fred Toepfer, and in this episode, we're diving into a powerful trend shaping the future of energy, battery energy storage systems, commonly known as BESS. As demand on the grid increases, driven by artificial intelligence, electrical vehicle charging, and the impacts these are having on an aging infrastructure, BESS is emerging as a vital solution for system stability and sustainability. Joining me today are Mike Janelle and Brandon Schuler, two experts who work directly with customers deploying these systems in the field. Mike brings over 2 decades of experience in the critical power industry, leading teams dedicated to ensure the reliability of essential electrical systems with a focus on battery energy storage systems. Brandon has over 20 years of experience in the critical power industry and serves as a technical expert in battery energy storage systems. He combines deep technical knowledge with strategic insight to support the commercial deployment of storage solutions across the energy sector. Together, we're going to break down what's driving the growth, how testing plays a role, and what the future holds for BESS. So get ready to unplug and connect. Mike and Brandon, welcome to Keeping Current.
Hey, Fred, thanks for having
us.
So let's talk a little bit about the momentum behind BESS systems. They have gained a lot of traction recently, but there are surely those in our audience who may not be familiar with the BESS solutions. Could you guys start by explaining what a BESS is and highlight its key components?
Fred, great question. At its core, a BESS system is designed to store excess electricity, often from renewable energy sources or from the grid during low demand periods, and discharges it when it's needed, such as during peak demand or during outages. BESS would typically include the following components. A battery is really the heart of the system. The battery, stores and releases the energy. Most commonly used currently is lithium ion due to its high density for energy. Battery management systems monitors and manages the battery. Performance tracking voltages, temperatures, state of charge. Then we have a commonly known as a PCS, a power conversion system, converts electricity between AC and DC, and then it would also include inverters that convert it from DC to AC. There is an energy management system that optimizes the operation of the BESS. It coordinates it with the grid and controls when and how much to discharge. And then, of course, you have to keep it nice and cool, maintains optimal temperature. They have a thermal management system. You also have your enclosure for your battery modules. It could be on a skid design, and then there's a safety and fire protection system.
Thanks, Brandon. I appreciate the detailed explanation. I know some of that, but I'm glad you sort of tied it all together to make me and hopefully our audience members understand it a little bit better. With that said, what's driving the explosive growth of BESS right now?
Hey, Fred, I'll take that question. There's a few factors driving BESS explosive growth right now. I think the very first one is the electrification of everything. It's really a revolution that started, probably 5 years ago. Started with EVs, electric vehicles, and then data centers kept expanding and growing. And then from there, when streaming came about, the edge network or edge data centers kept the demand for electricity increasing. And as of recent, to compile to this ever-growing electrical demand is AI and AI data centers. So the future looking forward is just exponentially growing on a demand side for the electrical grid. So that is what's driving explosive growth, because we cannot build power plants as fast as demand increases in society. So one of the solutions to this higher demand is the BESS systems. Renewable energy integration is storing the excess from renewable energy, such as solar or wind. So one important factor of why we have BESS as a good solution is those are intermittent energy sources. So when you have solar and wind, they're not on all the time like a power plant. So we're able to store the excess energy that those intermittent sources produce, and then use that energy at a different time when, say, the grid demand has a higher demand. Some other factors: modernizing the grid, decentralization. Many of the national grids are old and strained, so there are actually three grids in the United States. There's an East grid, a West grid, and then Texas has its own grid. So on those three grids, they are aging, and BESS is acting as a buffer that can provide frequency regulation, voltage control, and basically reserves for demand. The other interesting piece is governments and corporations are setting, net zero and carbon neutral targets. So this helps them enable their goals and their sustainability goals, and especially helps replacing fossil fuel-based electrical generation, including peaker plants. So the demand is so high in our grid that we had to restart a lot of coal plants as, band-aids to keep up with the demand.
Great insight into how that's being used. In fact, one of the things that I read in all the time in the newspapers is the concern about grid stability and managing peak demand, and I appreciate you taking care of that in your explanation. Okay, we talked about BESS in general, but let's get a little bit more into the details and talk a little bit about the testing of BESS. Mike, with your 2 decades of experience in the critical power space and your leadership in battery energy storage reliability, you've seen how essential thorough testing is, especially before systems go live. How do you ensure that a battery energy storage system is safe and functioning as designed before it does go live?
Great question. Safety is at the forefront of all of our minds, and working on energy storage systems no different. One way to ensure a safe and functioning design is before commissioning. It's a multi-layer process involving, a whole group of people, including engineers, validation engineers, regulatory compliance, since now we're tying to a grid. So there's, NERC involved and UL listing involved. And they also go through rigorous testing, not only at the factory level before it ships, but on site, make sure there's no shipping damage. And we also validate design to the drawings and engineering review with the team to make sure that we're not missing anything. So there's a lot of tie points, right? So you got batteries, you're tying into the grid. There's a lot that goes into these that need to be validated. So once we get there, then it's the factory acceptance test. It's one of the initial tests we do on site, basically consider that a startup. From there, it morphs into a site acceptance test where now we're started up and we're ready to start pushing and pulling power on the grid and testing the system. And then safety checks and compliance, very important when you're pushing and pulling power on the grid. These systems are sometimes loads on the grid and sometimes sources on the grid. So it's something that's a little bit different in our industry that we're not used to. We're used to traditional UPS being demand on the grid and not necessarily a source. So little differences there on how it performs. And then we go into performance and testing and commissioning. So that's basically, let's put this through its paces. Let's charge, fully charge, fully discharge, half charge. We do round trip efficiency testing. We do runtime testing, power quality meter testing, just to make sure that everything is working in a system. And then, of course, for closeout, documentation and training, very important that the system's validated, give the customer their paperwork that they know that this thing's been tested and they're comfortable operating it themselves and fully trained on it. Training can also include, since we're on the topic of safety, could also include, local facilities people, and sometimes local fire departments need training on these systems. So that's an aspect of these going out in, fields and colleges and things like that. And the fire department has to respond. They need to training on these systems as well. And then finally, certification, usually a process where UL will come out to the field and justify all the testing and wiring that we've done in the field and certify it as UL compliant. Is there anything else you'd like to add, Brandon?
Yeah, so I think you covered everything pretty well. I think you touched on round trip efficiency, and I think that was a point that I wanted to, just mention briefly. What is round trip efficiency? You're measuring the difference between charge and discharge. So it's the difference of energy that you're putting into the BESS system versus the energy that is coming out of the system. So that is to me one of the most important steps of the test. That way you can verify that hey, you're actually getting the ROI that you wanted from this system.
Great. So what kinds of issues or failures can be uncovered during final stage BESS testing?
Honestly, you can come up with a bunch of little gremlins. Most of the stuff is pretty minor. You get some configuration errors, but you also can get some serious safety risks. So you really have to look at the electrical and performance of the unit, have to look at capacity and shortfalls. You have to look into the inverter. Really, those tests that we were speaking about recently with RTE and the discharge test and the C rate test, those are critical tests to do to make sure you don't have any issues with the battery or the inverter or any of the safety checks.
So obviously a BESS system isn't necessarily standalone. It's got to integrate with renewable resources like solar or wind. How do we handle the testing that makes sure that connection is done flawlessly?
Honestly, outside of the stuff we were, kind of just going over, call it the normal testing, really the additional steps would be simulating a solar or wind test. How does the BESS respond to fluctuating inputs, cloud cover, wind drop scenarios? We would definitely want to simulate sudden dips in generation to test the ramping and backup capability. This basically just ensures the BESS can absorb the excess energy when generation exceeds the demands or the grid limits. So there's a few tests there that we do, but I think that encompasses all of them.
Okay, good. So it's not just the systems itself, but it's the people who are involved in constructing this project to make sure that it functions properly, which requires commissioning. So when it comes to commissioning, you have end users, you have third parties, you have owners, all have to be coordinated together. What are your thoughts about how that process should work effectively?
Honestly, I think it's absolutely critical to involve them into the process from start to finish. And I believe Mike touched on this a little bit, but they definitely have to be involved in the commissioning portion of it. And then you also want to add some of training pieces to it because, just commissioning the product and handing it over, that isn't the best way to go about things. A part of the process should be training, teaching them how to use their product, teaching them how to use it safely, and making sure they understand the ROI that they're receiving on the product they purchased. Mike, did you want to add anything?
Yeah, I'd just like to add that this is not a startup and forget it for our customers. So this is usually a 10 to 20 year partnership on the system that we install that we will support both on a technical level and a commercial level for a good 10 to 15 years after the unit is started up.
Good to know. It's not just install it and walk away. It's a constant commitment to making sure that this thing operates effectively over time. Thanks for the info. So let's talk a little bit maybe about real world applications and looking ahead. And let's wrap up with talking about the wheres. We've talked about the whys and the hows. Let's talk about the wheres. Battery energy storage systems aren't just a future technology. They're already being deployed in meaningful ways across industries, as you guys have talked about with your experience. Do you have any examples of a recent BESS project you've worked on and what made it stand out? Maybe it was the scale of the project, the application itself, or maybe the challenges of getting it implemented correctly.
Yes, I have two projects I've recently worked on. So one thing I got to see is how dynamic today's BESS inverters really are. We installed a 1.5 kilowatt system at both locations, and during commissioning, something that jumped out to me is the bidirectional inverter, right? So these inverters can charge and discharge, which we all know from the previous segment. But what's really interesting is how fast they can actually change they can go from charging 1.5 kilowatt hours to discharging 1.5 kilowatt hours in literally seconds. I mean, that's just the response time of these inverters is just phenomenal, which is exactly what we need to check off all those power quality issues that we discussed earlier with the grid. So when you think about that, that's a 3 kilowatt hour power swing almost instantaneously. It's that allows us to enable during fast changing loads. So AI data centers are fast changing loads, peaks and valleys of load that really aren't that predictable. So these systems are really the buffer between the grid and the data center for that. It also opens the door for things like frequency regulation and ultra rapid peak shaving. Things we used to dream about with traditional electronics, they're now a reality with these new inverters and batteries. So now let's zoom out from our 1.5 kilowatt systems. You asked about scale. So we were working on a little 1.5 kilowatt system, which at the time we thought, wow, that's a lot of power, right? 1.5 kilowatt hours is a lot of power. We're actually in the process of bidding a monster 1.2 gigawatt energy storage system for an AI data center. That's not kilowatts anymore. We're talking gigawatts, 10,000 times power and energy that we previously discussed. And then you also talked about a challenge. So one challenge and critical piece to consider is personal safety, because you can operate these systems remotely. You could be thousands of miles away. Someone can log in and operate these systems. So on the upside, this remote control lets site technicians minimize exposure. So they can be 100 feet away, 300 feet away, operating breakers and operating the inverter where they're not standing in front of it. So that's a definite positive on the upside for safety for our technicians. On the downside is our techs need to be cognizant that these things can be remote controlled, and we need to have a way to defeat that remote control when we're working on it for safety reasons, so that no one can operate breakers unintendedly when we're working on a system for maintenance. So when digital commands can open and close a breaker from miles away, you really got to build safety into every layer. That's software, hardware, processes, and yes, every person on site. So it demands rigorous people-centric safety training for these systems.
Mike, the only thing I'd like to add on top of that would be just a brief comment about cybersecurity. It is definitely on the forefront of most people's brains now that, outside of the technician, outside of the customer, people can hack into the system, and we need to have constraints and protections put in place to prevent that from happening. So it's not just a safety, but it's also a security of the system to where somebody can't remotely hack into it.
Does that also cover NERC requirements for cybersecurity for utility systems?
It does.
In my experience in the electric utility, that's a big thing. So we're probably already involved in that in other areas, and it's again just an important thing with BESS as well. So just a couple of other maybe follow-up questions. How does the BESS deployment demonstrate the real-world value and impact these systems can have on a customer? I heard a little bit of that from you, Mike, but I thought maybe you guys would elaborate just a little bit more.
So one way to think of BESS is your secret weapon against pricey demand charges. If your facility has a peak demand, these systems can shave the peak power that your facility is taking and reduce your electrical utility demand pricing. It's a simple move that can cut fees of the electrical bill for our clients up to 30%. And in short, it's like building in a hedge for your electrical bill, protecting your budget and every month going forward.
Brandon, any further thoughts?
No, I think Mike kind of covered that one pretty well. That's really, especially on the commercial end of things, the trying to shave that electric bill. I think that's where the big ROI for these customers really is.
So now just BESS in general, BESS yes or BESS no? What should organizations consider before investing in energy storage solutions?
So Fred, really, they got a few things to think about, but realize first that BESS is not a one-size-fits-all. There are a ton of factors that go into it. They have to do an energy need assessment, system compatibility. What type of, are you going to tie it into solar? Are you going to tie it into wind? Are you going to use the grid for charge discharges? Storage type, the real capacity that you want, and performance and reliability. I mean, there's just a lot to consider before somebody just goes out and says, I want a BESS system. It's a much bigger, broader topic than just that.
Well, BESS systems are what they are today, but just like anything else in our industry, particularly stuff that's tied to data centers and AI, things are going to change. So where do you see BESS heading over the next 5 to 10 years?
Honestly, I think the future of BESS over the next 5 to 10 years is shaping up to be a very transformative, driven by technology, innovation, some policies. Now, some policies are constantly changing. So you have to stay in front of those policies. A global push for decarbonization. One of the things I'm really keeping an eye on is batteries. Where are they going, and what is on the forefront? And there is an ever-changing technology. 10, 15 years ago, we started with lead acid. Then you turned into valve regulated. Then it turned into NiCad. And then it turned into lithium ion. And the future potentials, could it be solid state batteries? Could it be sodium ion? Could it be flow batteries? Could they be doing second life batteries to where they're taking the EV batteries and putting them into these systems? It's just, I think the battery technology is what's going to drive this in the future. And I think that's what I really want to watch.
Mike, anything to add?
Yeah, I just want to reiterate what Brandon said. I think it's twofold. Where it's heading in 5 to 10 years, I mean, no one really knows for sure, but the way it's just headed in this last year, it is rapidly increasing at a rate that I'm not sure the industry's seen in previous years. And it's all going to depend on, like Brandon said, what battery technologies are going to be discovered between now and then, and how much more demand increase is going to be. I'm not sure anyone can predict that. And just a little irony here, they're actually using AI technology to research new battery technologies. So it's almost like a self-feeding system in that aspect.
Well, great. Hey, guys, I really appreciate you, Mike and Brandon, sharing your insights into the world of battery energy storage. You've covered a lot of ground, had a lot of good insights, but any final thoughts you'd like to share with the audience?
I do, and I think Mike hit the term right on the head early in this segment. The BESS between now and 2035, maybe 2040, is poised to be revolutionary. It's driven through technology, breakthroughs, climate policies, global shifts towards renewable energy. And I think Mike was really spot on when he used that term earlier, revolutionary.
Yeah, I mean, honestly, from my perspective, what a time to be alive. This is really the foundation electrical that for AI and data centers and things. It's world changing, it's people changing, and to be here for it is just an honor, and we'll see what's coming.
Fantastic. Again, guys, great. Thanks for your insights. That's it for this episode of Keeping Current. If you found today's conversation valuable, make sure to subscribe, leave us a review, and tune in every other Thursday for more expert insights. You can connect with us on LinkedIn and stay in the loop. And as always, thank you for listening. Until next time, keep current.